Welcome to Kotlin. This video is part of a series where we're building Minesweeper with Compose Multiplatform. Whilst it's designed to be useful on its own, there may be some references to earlier episodes. Right, so the first thing we're going to add is the dependency to our UI core module, and this will be for the Compose UI test library. So we'll add that here. We'll use API so that we can access it from any other module that's dependent on UI core. Here we can just use compose.UI test. This is currently experimental, so if we press Option Enter on Mac, we can opt in for experimental Compose library. The other dependency we need, we'll add to the feature that we're going to actually do the UI tests on. And this will be feature play in our case. And here it will be inside of the commonMain dependencies, and we'll say implementation Kotlin with a string of test. And this is because we're using the Kotlin test framework for this case. We'll sync this. If we remember back to the earlier episode in which we created the Minesweeper board UI, I'll show it on screen now just as a reminder. We're going to add some UI tests for this Minesweeper board. So to start, we'll create the common test folder. So we can do this inside of feature play source, new directory, and here we can add common test/Kotlin. Now here we'll match the package name of the module. In our case it's com.kotlin.minesweeperk.feature.play. And inside this we'll create Minesweeper board test. Now this should be a class, and within here, using the Kotlin test framework, we can create our tests as functions. So we'll use the test annotation coming from kotlin.test, and the first test we're going to do, we're going to check that the correct number of tiles show on screen for the board size that we give it. So we'll just name this something that describes what it does. So correct number of tiles are shown. Now here we can use run compose UI test. So this is coming from the library that we've just added. And we need it's currently experimental, as there's a lot of things in Compose at the moment. So we'll just opt in for that. And the first thing we'll do, we need to actually create the tile states to show on the board. We'll use set content first and add the Minesweeper board that we've created. We'll just click in for a quick reminder. It needs a list of tile states, and this is ordered in a way where it's x axis first and then y axis. And for the modifier, we'll just use modifier.fillMaxSize. Now we need to get these tile states from somewhere. If we go back into our Minesweeper board, as you may remember, when we were looking at the previews, we created a helper function at the bottom here of getting all possible tile states. We'll just copy this and place it straight into our test. Now from this we can create another helper function. We can name this get random tile states for size. This will take in a width and a height, and it will return the list of tile states. Now I'm just going to return an empty list for now. We'll implement this in a minute. But what we need to do is create our test cases for this test. So we'll just create a few. We'll just use a list, and we'll just use pairs that will contain the list. Well, it'll contain the tile states and then the expected number of tiles from those states. So within here, we'll start by a width and height of 0. Now for the expected results, I'm just going to use -1 for all of them now, just so that we can see the tests failing firsthand, and then we can then get them to work properly. So we'll duplicate this a few times, and I'll just put a couple of different size boards, so 10 by 10, and we'll say 30 by 16. Now we'll implement this function. So to start, we'll get all of the tile states available, and we'll build a list, and we'll say for x in 0 until width, we can add, and we'll need to build another list here and do the same for the y direction, for y in 0 until height this time. Now we can add from all tile states .random. Now we can see random takes in a parameter of the random class, an instance. We want to actually pass this through just to reduce the chance of any flakiness in the test. So we'll create a random up here. And give it a seed. It doesn't really matter what the seed is, we'll just use 1 for now. And we'll pass that through to this function and use it here. So that's passed through, and yeah, this should just provide the tile states for the width and the height. Next thing we need to do is create a mutable state of the tile states. We'll give it the type. We can say by mutable state of, and give it an empty list to start with. Import that, and we can pass through the tile states. Now the next thing we need to do is loop through all of the test cases that we've written up here. Let's say for each test case in test cases, we can update tile states to equal test case dot first. So that's what's in the first entry of the pair. And we need to wait for idle, so that we're giving this a chance to recompose since tile states has been updated. Now we can find the nodes that are the tiles and check how many exist. So we can use on all nodes for that. Now here we can use any matcher we like. For this we'll use a test tag. We can just check whichever composable has a test tag of tile. This doesn't exist at the moment, so we'll need to add that into Minesweeper board. So if we scroll up, and we can find our tile composable, which is here, and in the modifier we can just add test tag and give it a name of tile. So going back to this, we're now getting all of the nodes that have the tile test tag. So this is going to be all of our tiles. So we just simply need to assert that the count of this is equal to our test case dot second, which is this value here. So that should be everything we need for this first test. We'll run it. Now desktop needs the least setup. And for our case, this is just using common code. It's going to look the same across all platforms. We'll just run it on desktop. And as you can see, the test is failing. So this is just because it's expecting -1 here, but it's obviously going to be 0. That's the amount of tiles that it should show. So we'll change that to 0 and rerun it. And again, this is now failing the next test case. So this is 10 by 10. So we know that's going to be 100, but just to show where that's coming from, I'll just type in here as 10 by 10. And lastly, this should be 30 by 16. We'll run that. And our tests are now passing. Now, one thing I noticed after recording the Minesweeper UI episode is there is a bit of a problem with how I'm calculating the board height and board width here. I've mistakenly used remember, so this size, once it's calculated, is stuck. It's going to always be the same. So then if a new set of tile states comes in, this board height isn't going to be correct anymore. So we can write a test to showcase this, because what's going to happen is the tiles aren't going to be square. It's going to be calculating the tile length based on an incorrect value. So if we go back to the test, we'll create a new test. And we'll name it all tiles are square. And again, we're using run compose UI test, opt in for experimental API. Now we'll get a first set of tile states. We can use our helper function again, and this we'll just use 10 by 10. We need to pass in an instance of random again. It doesn't matter what the seed is, we'll just create a new instance here. And then we need a second lot of tile states. And here we'll just use expert size, so 30 by 16. Then similarly to what we did before, we can get the tile states using mutable state of. Now we'll just pass the first tile states in directly. Set the content. And again, just modify it or fill max size so we can use all the space available. Now we'll write a function inside this function that's just going to do the assertions for checking the width and height of each tile, because we're going to need to call this, well, do these operations once for the first set and then again for the second. So we can just call this test tile sizes are equal. Then we can get the tile semantic nodes. Again, we're going to use on all nodes, just similar to what we've done up here with the has test tag tile. We can call fetch semantic nodes. So what this does is give us a list of the semantic nodes. I'll just show you what sort of properties that has, but we can get things like its size or ID, position and route, just things like that. Obviously what we care about is the size. So we'll say tile semantic nodes dot for each, and we can use assert true. That's coming from the Kotlin test framework. We'll give it a message for if it fails. Here we can say if the size dot width, we'll just give it a name here so we can see what it's talking about, does not equal the size dot height. So that's what we're going to actually be testing. Size dot width is equal to size dot height. Now we need to call this, and then update the tile states. wait for any recomposition, and then recall this function. We'll run that, and it's failed. And this is to do with how we've created the Minesweeper board. So if we go back and look at our tile length, we can see that the row that houses all of the tiles is using that to actually create the size of where it can place the tiles, but the tiles themselves are just filling the space available evenly. So this can be off by 1 pixel either way. In our case, this is fine. It's, you know, they're not going to be perfect squares in some cases, but for our use case, it's not the end of the world. But we will need to check for this in our test. So we can just check the absolute value between the two. And this should be either 0 or 1, or just more importantly, just less than or equal to 1. So this just allows for the case that we've just seen. I've lost the test result, but it had a width of 76 and a height of 77. As I say, that's fine. We'll rerun that. Now this is where we're seeing the problem. So this is when it's running the second time around. The tile states have updated. So it's now using a list of 30 width and 16 height, but it's using the tile length for 10 by 10. So that's what's skewing this. We'll go back to Minesweeper board and fix that. So these need to be recalculated every time. Now what we'll do is allow it to be passed in. We'll call it board width, which should be an int, but we'll give it a value to start with, which will be tilestates.size. And we'll also pass in a board height that's calculated, and here we'll say dot first on null. And if that exists, we'll use its size, otherwise 0. So we can get rid of these 2 lines and we can rerun that. And as you can see, the test's now passing. So we've just added 2 fairly simple tests here, just for checking the correct number of tiles are shown, but also that all the tiles are square. I'm going to rename this to roughly square because, as I say, it's allowing 1 pixel either way. At the time of recording this video, you may only use desktop or iOS simulator for running UI tests on Compose Multiplatform. I'll just run the tests now on the iOS simulator to show that it works. This has been a shorter video than usual, but I hope you found it useful. If you've been enjoying the series, then make sure to subscribe and leave a star on the GitHub repository. Thanks for watching.